Hello students, start the second part of the introduction of maxima and minima. In the last lecture or last video, we have discussed the first derivative test to calculate the point of maxima and point of minima. Now we are going to discuss the second derivative test to calculate the point of maxima and point of minima. In the last lecture, we discussed a point which was the point of inflection. So what is the meaning of point of inflection? तो इसको समझने के लिए हम एक एग्जांपल लेते हैं।
गाइस आपने अभी तक हमारे चैनल को सब्सक्राइब नहीं किया तो प्लीज़ इस चैनल को सब्सक्राइब कर ले और साथ ही में गाइस बेल आइकन की घंटी को भी प्रेस कर दे ताकि हमारे आने वाले वीडियो नोटिफिकेशन सबसे पहले मिले आपको।
5x cube plus 3 is a function of x. According to the first derivative rule, first of all we will differentiate with respect to x. Then it will become 15x square, and after it equating this derivative with 0, then we'll get 15x square is equals to 0, and from here we will get x is equals to 0. According to the first derivative rule, this is extreme point, and on plotting this extreme point on the number line, now we'll check the symbols from the left side or the right side of the extreme point of this function. So in the left side all the values are negative, and in the right side all the values are positive. So I am selecting, and the two intervals are here. First is the negative interval and second is the positive interval. From this interval I am selecting any value. Just imagine I am taking -1. At -1 I am checking the value of this derivative function, which will be equals to 15 minus 1 whole square, which is equals to 15, and which is greater than 0, that means positive. And again I am taking another value from the right side of this extreme point. Just imagine I am taking +2. So f dash 2 is equals to 15 2 whole square. So 15 4 ja 60, which is also greater than 0, and again our value is. Our conclusion is, from left to right, on moving from left to right to our extreme point, which is equals to 0. Left to right, here the symbol is positive, and here also the symbol is positive. When we move from left to right, the symbol will not change. That's mean at this point our function fx is neither minimum nor maximum. So this point is known as point of inflection. Okay students, I think you are getting my point. Now for the next topic, let's start the second derivative test to check the value of maxima and minima, and minimum value and maximum value of the given function. It's very easy, just try to understand. So first of all, just imagine any function y is equals to fx is given. First I am writing the heading. Just imagine any function y is equals to fx is given. Differentiate this function with respect to x and equate it with the 0 to calculate the extreme point. Let's suppose after calculating we get some extreme points which are like either x is equals to c1 or x is equals to c2 or x is equals to c3. After calculating these values, we will differentiate again the given function with respect to x, means second time derivative. After calculating this value, we will apply one by one these three values in this function. So at c1, the value of the second derivative, let's suppose it is maximum, it is greater than 0. Let's suppose at point c1 the value of the second derivative is greater than 0. Then c1 is point of minima, and the value of function at c1, the value of function at c1 is minimum value. Now the second case, if the value of the second derivative at any extreme point is less than 0, I am checking for C2, just I am taking an example. If the value of the second derivative at C2 is less than 0, then C2 is point of maxima. And third case is also available, possible, which is if the value of function at any extreme point is equals to 0, then check the first derivative test and find the symbols either side of this point. If just imagine this type of the symbol you will get, then at this point our function will be maximum. That means C3 is the point of maxima, and if we will get the symbol like this -2 plus, then C3 is the point of minima, and at these 2 points, at this point our function will have the minimum value. Example, so let's take, just imagine a function y is equals to 2x cube minus 15x square plus 36x plus 1 is given, and we are going to calculate the value of minima and maxima. According to the question, find the value of minimum value of the given function. So first of all, find first derivative. It is also equals to fx. So find first derivative f this x, which is equals to 6x square minus 30x plus 36. And after it, according to the first derivative, second derivative rule, equate it with 0 to find the extreme points. So from here we'll get 6x square minus 30x plus 36 is equals to 0. Find the value of x. So 6 is common, x square minus 5x plus 6 is equals to 0. And two factors are here, x minus 3 and x minus 2. Middle part is splitting method. And from here x is equals to 3 or 2. Two values are there. First is 3, second is 2. And now again differentiate this with respect to x, means find the second derivative f double dash x. which is equals to 12x minus 30. 12x minus 30. And now apply this and this value here. So f double dash x at x is equals to 3 is equals to 12 into 3 minus 30. So 36 minus 30. 36 minus 30 is equals to 6, which is greater than 0. It means at x is equals to 3, f x has minimum value, and x is equal to 3 is point of minima. Check for x is equals to 2. F double dash x at x is equals to 2. 12 into 2. 12 into 2 minus 30, which is equals to minus 24 minus 30 minus 6, which is less than 0. So x is equal to 2 is a point of maxima, and fx has its maximum value to. So students, this is the method to calculate the maxima and minima, means point of maxima and point of minima, and after it we will apply x is equals to 3 and x is equals to 2 in this function, and we'll get the, for this point we'll get the minimum value of the function, and for this point we'll get the maximum value of the function. So I hope you understood by the this video or this lecture, and in the next video we will discuss about some examples, some questions of the related with the book NCERT, RBSE, etc, etc. And if you have any doubt or any query, then you can please send with any comment. I'll try to solve all the questions, all your doubts.